we pass the object files first before the libraries, and then the symbols in the object files are preferred over the ones in the library. This allows us to mask or replace library functions. Let's have a look how this exactly works in Eclipse with Mockator. I have a project here that is similar to the others, with system under test game 4 wins, a unit test with Qt, and a static library project which has the implementation we want to replace with our own. So we want to replace rand with our own version. Then we choose source, shadow function, voila, we have a new translation unit with the definition of rand. Okay, that automatically includes the necessary system includes, and it returns a default value. So that's basically it. So of course we don't want to return the default value, but instead to make our unit test work, we return 3 here. So if I now compile this again and execute the test, we have a green bar. So that was shadowing a function, and you see all shadowed functions are created in a new source folder called shadows. If you want to get rid of them, you just delete the files, or if you want to get rid of all, then you just delete the shadows folder. Okay, that was shadowing functions. They have an important disadvantage. As you have seen, that it's not possible to call the original function anymore, so it's really a shadowing. Wrapping functions helps us to call the original function, so we just wrap it, we do not shadow it, the function. It's based on the wrap option the GNU linker offers. In the man page of the linker, this functionality is described like this. We use a wrapper function for a symbol, and any undefined reference to that symbol will be resolved to wrap symbol. Any undefined reference to real symbol, to the real function, will be resolved to symbol. So I think it's best to have to see an example. Wrap function, use the same system under test, the same implementation. This time we wanna mock or wrap the role member function of die, because I would like to show you that it also works with C++ member functions and not only with free functions from the standard library. So yeah, I mark this member function and say source wrap function. Et voila, you see new code has been created. And yes, I have to explain that as it was written in the man page, we have here the wrapping function. You see, this is the mangled name of the C++ member function die role. Mockator automatically mangles this name and creates a delegate to the real function. Real function is declared here. So we can insert our additional functionality before we call the real function, like if you would like to lock something. But in this case we do not want to call the original function, but instead we just want to make our unit test green, so we return 3 here and build and execute our test. Oops, and of course I need to return 4 here in this case and not 3. So We do it again. And now we have a green test. As you see, Mockator created a marker here. You can always deactivate it or even delete the wrapped function by a quick fix. Mockator creates a linker option in the project settings. See here, this is the wrap option, and we pass the mangled name of the function we want to wrap here. So that was wrapping functions, which allows us to call the original function if you would like to. The wrapping function has a few disadvantages. It only works with the GNU linker on Linux platform. Unfortunately, it's not available on Mac OS X, and it does not work with functions in shared libraries. So we can only wrap functions in static libraries. Because of this, we introduce a third kind of scene, which is called runtime function interception. This allows us to wrap functions in shared libraries. It's based on the fact that we can alter the runtime linking behavior of the dynamic linker LD and inject shared libraries to be loaded before the ones containing our code we want to wrap. So I think it's best to have a look how this exactly works. Here we have another project with the known system out test, the unit test in Qt, and now a shared library project with the function we would like to wrap. So this works exactly like wrapping functions in static libraries. We choose source wrap function, but this time Mockator creates a new shared library project with the function we would like to wrap, and as you see, it's still possible to call the original function by using the functions of the dynamic linker to load the original symbol, and then we cast it and call it here. So this has the same advantages of the wrapping functions, that it's possible to call the original function, but it also works with shared libraries. So in this case we do not want to call the original function, but instead we just want to return 3 here to make our unit test work. And Mockator automatically created a runtime configuration. Let's have a look at that. That's in preload function, and you see here it uses the environment variable ld preload to load our shared library with the wrapped code before the others. So another important advantage is that we only need to recompile to create the shared library. If something changes, we do not need to link the other code to the newly created shared library in that case. So we execute our unit test now. Et voila, we have a green bar. Mockator also allows us to temporarily deactivate the wrapped function by clicking on the project. Mockator maintain runtime wrapping. We see here the referenced shared library project with the wrapped function in it, and if we click on it, then the original code will be taken again. We can always reactivate again. So that was preloading functions with the dynamic linker, and its advantage is that it also works with shared libraries, of course, and that both Linux and Mac OS X are supported. A disadvantage is that it's unreliable with member functions, because the size of the member function pointers is highly platform specific, so it's better to use free functions with this kind of link scheme.